Hello, everyone. Today, we're going to go ahead and do a recap of some of the topics that we covered yesterday on object oriented programming with Java, and then we'll continue from where we left yesterday. So, we'll start with the operators. There are different operators such as unary, arithmetic, shift, relational, bitwise, logical, ternary, assignment. Unary has postfix and prefix. Arithmetic has multiplicative, additive. Shift has shift. Relational has comparison, equality. Bitwise has bitwise and bitwise exclusive or, bitwise inclusive or. Logical has logical and logical or. Ternary has ternary, and assignment has assignment. Okay, so these are your operators. And then we will talk about the statements and expression. So let's take a look at it. In Java, each statement is a complete unit of execution. For example, int score equals 9 multiplied by 5, semicolon. So this as a whole is a statement. So, and a part of it, like 9 into 5 is actually an expression, or score equals 9 into 5 is an expression. So for if you want to convert expression into a statement, it must end with semicolon. Here we have a statement. The complete execution of this statement involves multiplying integers 9 and 5 and assigning the result to a variable score. In the above statement, we have an expression 9 into 5. In Java, expressions are parts of statements. Okay. So expressions are parts of statement, and each statement is a complete unit of execution. So we can make this bold. Make this bold. Right. We can convert an expression into a statement by terminating the expression with a colon, semicolon. Okay. These are known as expression statements. For example, number equals 10 is an expression, and number equals 10 followed by a semicolon is a statement. Okay. So statements are complete unit of execution, which includes the semicolon, and expressions are part of statements. In above example, we have an expression number equals 10. By adding a semicolon, we have converted the expression into a statement. Okay. Now, expression consists of variables, operators, literals, and method calls. For example, int score semicolon and score equals 90 semicolon. Here, score equals 90 is an expression that returns an integer. Double A equals 2.2, B equals 3.4. Result A plus B minus 3.4 is an expression. If number one equals number two, here number one equals number two, which returns a Boolean value, is an expression. And number one is larger than number two is a string expression. Okay, now we talk about the scanner classes. So scanner classes is a part of the Java library, and it's available inside of java.util package, and it's used to read the input data from different sources like input streams, users, and files. Let's take an example. Let's say we import the scanner class from the util package, and then we use it by first instantiating this class, creating an object called input of type scanner, new scanner. We have to pass system.in, which basically takes the input from the user. Then we print a message saying enter your name, then string name equals input.next line. So this method that's available inside of the input will read whatever user has entered in the keyboard and store it inside of the name variable, and then we'll just print it. And then we close the scanner using input.close method. Okay, talk about decisions and loops. For decision loops, we have if-else statements, we have switch case statement, dump branching statement. They're used with for, while, and do while. It includes break, continue, and return statements. You have while loop, you have do while loop, for loops. This is a program to display numbers 1 to n. We use a scanner class, create an instance variable, a variable which is inside of the class but outside the method. It's accessible in the entire class. And we have the main method, some of the variables that we've declared. We create a variable called sc and instantiate the scanner class pass system.in, and then we print saying please enter the number, and then we take the input from the user. This will read the input whatever user has entered from the keyboard, next int, and then we loop through for as long as whatever number user has entered is less than equal to the value of I is less than equal to whatever user has entered. Then you just keep printing that number and keep incrementing the value of I. Program to print the odd numbers between 0 to 10. So we have this main function int n equals 10, system out dot print for int I equals 1, I less than n, I plus plus. Okay, so this is going to print all the odd numbers between 0 to 10. We talk about assertions and exception handling. So assertions and its use. Assertion as per dictionary means declare positively. An assertion is a statement in Java which ensures correctness of any assumptions which have been done in the program. When an assertion is executed, it is assumed to be true. If the assertion is false, the JVM will throw an assertion error. It finds the application primarily for testing purposes. If conditional statement used to check bug condition reach the production, even after the bug has been removed, they consume CPU cycles and may be the cause of the bottleneck or resource crunch. This problem does not exist with the assertions as they are disabled by default. So by default, assertions are disabled in Java. In order to enable them, we use the following command, which is java hyphen enable assertions and then the name of the Java file. Okay. Now, to sum it up, assertion basically ensures the correctness of any assumption. When the assertion is executed, it is assumed to be true. By default, assertions are disabled in Java, but we can enable it using java hyphen enable assertions and the name of the file. Okay. Then writing an assertion. Assertion in Java can be done with the help of assert keyword. So first way is assert and then expression, or assert expression 1 colon expression 2. So here in the main class, we declare an integer. We use assert age less than equals to 18. If the result is false, then we'll get cannot vote. Okay, and then the next line will print, which says the voter's age is so and so. Okay, when assertion fails, it usually throws assertion error when the assumption made is wrong. It extends the error class, which ultimately extends the throwable class. Catching exception error, an assert statement declares a Boolean condition that is expected to occur in a program. If this Boolean condition evaluates to false, then assertion error is given at runtime provided the assertion is enabled. If assumption is correct, then Boolean condition will return true. Assertion are not required to declare them explicitly, and there's no need to try or catch them. So unlike an exception, which we are supposed to try and catch, for assertion, we don't really have to catch. We can just declare it to be true or false. And then if there is an error, it will throw the assertion error. Asserting an exception. To assert an exception, we declare the object expected exception as follows. Public expected exception, exception equals exception dot none. Then we use the expected function and expect message methods in the test method to assert the exception and give the exception message. Okay, what is an exception and its causes? So exception is an unwanted or unexpected event which occurs during the execution of the program at runtime that disrupts the normal flow of the program's instructions. So if you don't handle the exception, then the program will terminate and it will not continue. But if you do handle it using try catch method, then program will continue to run without any issues. And then whatever we have print asking the system to print will print that error. When an exception occurs within a method, it creates an object. The object is called an exception object. It contains information about the exceptions, such as name, description of the exception, and state of the program when the exception occurred. Causes of exception, for example, invalid user input, device failure, loss of network connection, physical limitation, out of disk memory, code errors, opening an unavailable file, JVM has run out of memory, etc. So, just to recap, exception is an unwanted or unexpected event which occurs during the execution of the program, that is, at the runtime, and it disrupts the normal flow of the program. When the exception occurs, it creates an object which has a lot of information about the exception. Different causes of exception are invalid user input, device failure, loss of network connection, physical limitations, code errors, opening an unavailable file, and JVM has run out of memory. Example of exception handling in Java. So various methods of exception handling are used. For example, try, catch, finally, throw, throws. This part I've already done. Okay, we can also pass exception in the catch method param that will catch all types of exception. But if we just pass specifics like number format exception, that will only catch the number type of exception, number format type of exception. Example is here inside of the main, you have try, catch, and finally. Finally will always get executed irrespective of whether uh, there has been an exception or not. It'll check this code. If there's no error, it'll continue to execute. But if there's an error, this will go inside of the catch and it'll print that. Okay, exception hierarchy. All exception and error types are subclasses of class throwable, which is the base class of the hierarchy. So we have an exception object, like I explained earlier, that you have the exception object available. It has a lot of information about the exception. So you have that object. There's a class called throwable. It has two different classes that extends throwable. One is exception, second is error. And then inside exception, you have other classes which are more specific to the type of the exception. One branch is headed by exception. The class is used for exceptional conditions that the user programs should catch. Null pointer exception is an example of such an exception. Another branch, error, is used by the Java runtime system to indicate errors having to do with the runtime environment itself. Stack Overflow is an example of such an error. Types of exception. So there are two types of exceptions. One is built-in, and second is the user-defined exceptions. Built-ins are the ones which are part of the Java library itself. There are two types: checked exception and unchecked exception. Checked are the ones which are compile time exception, because these exceptions are checked at compile time by the compiler. Unchecked are the ones which are not checked at compile time, and the program would not give the compilation error. These are at runtime. For example, divide by zero, array out of bounds, null pointer exception, etc. User defined. Sometimes the exceptions are not available in the library. At that time, we can create our own exception. These are user defined exceptions. Example of creating user defined exception. So you extend the exception class with your own class. Inside of that, you can define your own function and call the constructor of the exception class with the help of super method, and it takes a parameter. Then inside of the main function of the main class, you can do try and catch. You can throw an exception. by instantiating your class that you've declared on top, passing whatever values you want to pass. And then you can catch the error uh, in the catch body of the catch method. Okay, and then you have this object available called ex. It has different functions, and you can get the message. You can call this method to get the message. And I think exception belongs to the java.lang package, right? Then we have throw and throws. The throw keyword is used to create custom error, while throws keyword indicates what type of exception may be thrown by the method. Okay, so throw to create custom error, and throws indicates the type. Throw is explicitly used to throw an exception, but throws is used to declare an exception. Throw is followed by an instance, and throws is followed by a class. So throw is followed by an instance of the class because there's new, and throws is followed by the class itself. Throw is always used within a method, and throws is used with the method signature. So throw is used inside of the method, and then throws is used with the method signature, which is here next to the method name. Throw clause can throw only one exception and not multiple. Throws can declare multiple exceptions. Okay, then we talk about packages and interfaces. A package is a group of classes and subclasses, um, interfaces, subpackages in Java. And they must be similar type of classes, interfaces, and subpackages, just like a folder in a file directory. For example, when you write an application program, there may be many individual classes. You can place related classes into a folder and name this folder for organizing these classes and call it a package. They are used to avoid name conflicts and to write better maintainable code. So, two different packages can have the same class name, but because they reside in two different packages, then we don't have to worry about the name clashes. Accessibility rule for packages. There are different accessibility rule for access modifiers like private, public, protected, and default. You can limit the access of the classes, methods, variables throughout the package by using access specifiers or access modifiers. Three main access modifiers: private, public, protected, and then you also have default. You can declare anything public, which means it's publicly available inside the package or anywhere outside the package. Anything declared as private is only available within that class, unless you use getters and setters to use them inside of a child class. If you declare it protected, then the code is accessible in the same package and its subclass present in other packages. So same package and its subclass in other package. When you do not mention any access modifiers called default, which is available to the subclasses and other classes in the same package. So for protected, it's accessible in the same package and subclass of other packages. Default uh, to subclasses in the same package only. Okay. Finding packages and class paths. Java runtime system looks for packages from three paths: current folder. First, Java runtime uses the current folder working directory as its starting point. If your package is in subdirectory of the current directory, it'll be found. Or then it looks for class path if current folder is not available. Second, you can specify a directory path by setting class path environment variable. And third, you can use hyphen class path option with Java and Java to specify the path to your classes. For example, consider the following specification: package mypack. In order for the program to find mypack, one of the three things must be true. Either the program can be executed from a directly immediately above the mypack, or class path must be set to include the path to mypack, or class path option must specify to path to mypack when the program is run via Java. When the second two options are used, the class path must not include the name of the package. So in the second example, we don't have the name of the package, but if we are doing it with the first option, which is in the current folder, then we specify the name of the package. Types of packages and creating a package. There are two types of packages. One is built-in and second is users defined custom ones. Built-in packages are packages from the Java uh, API. There are packages from, I think we're doing it twice, from the Java API. It's the same thing. Package, there are packages from Java API, for example, Swing, Util, Net, IO, AWT, Lang, and JavaX. Importing a package, we use import, then the package dot name, example java.util. If you use star, it's going to import all of the classes. User-defined packages, you can create your own package by using the keyword package and then the name of your package. A package can be created by using the keyword package followed by the package name. Example, to create a class inside a package, first declare the package name on top, the first statement of your program, then we can include any class like so. In order to generate the above desired output, first do use the command as specified by the following specific commands. To generate the output from the above program, you use java welcome.java, which is the name of your class file.java. Our program will give us welcome.class file. Then we run the command java-d dot welcome.java. This command will create a new folder called first package. Okay, so java first package.welcome. Above will give the final output of the program. So this will give the final output, which is whatever we're printing here. Okay, so we use java welcome.java. This will create a welcome.class file. Then we run this command, welcome.java. This will basically create a new folder called first package. And then finally, this command will run whatever the main function is. So it's going to run this and then output that. Okay, so interfaces. So as we talked about earlier, that classes are blueprint, which you can use to create objects of similar types using methods and properties. And interfaces are basically blueprint of the classes, which have static methods, etc., and abstract methods, static constants and abstract methods. In Java, an interface is syntactically similar to the classes, but they lack instance variables. Instance variables are those variables which are inside of the class but outside the body of any method, but they are accessible throughout the class, unlike the local variable, which are part of the method itself and they're not available to the outside world. Okay, so they lack instance variables. It means that the interface can contain only constant declarations, method declarations, default methods, and static methods. Advantages of using an interface, they allow us to do multiple inheritance, used to achieve total abstraction, used to achieve loose coupling. So total abstraction, loose coupling, I think we should underline this. Total abstraction, loose coupling, multiple inheritance. Okay, now difference between abstract class and an interface. Abstract class can have abstract and non-abstract methods. Interface can only have abstract methods. It can have default and static methods. Abstract like does not support multiple inheritance. Interface supports multiple inheritance. So if you remember about abstract classes are those classes which are created with an abstract keyword, and they can have abstract methods, and they cannot be instantiated. They can only be implemented. You can extend it, and any child class that extends an abstract class must implement all of its methods. Okay, so abstract class can have final, non-final, static, and non-static variables. Interface only has static and final variables. Abstract class can provide implementation of interface. Interface can't provide the implementation of abstract class. The abstract keyword is used to declare an abstract class, and interface keyword is used to declare an interface. An abstract class can extend another Java class and implement multiple Java interfaces. An interface can extend another Java interface only. An abstract class can extend using keyword extends. An interface can be implemented using implements. A Java abstract class can have class members like private and protected. Member of Java interface are public by default. Example, public abstract class shape. Example of interface is public interface drawable. Okay, so now we'll talk about declaring and implementing an interface. Just one second. Just add some animation quickly. Okay. Okay, so Maya, can you read this?
Yeah. Declaring and implementing an interface. An interface is declared by using the interface keyword.
Okay.
It provides total abstraction, means all the methods in an interface are declared with the empty body, and all the fields are public, static, and final by default.
Mm-hmm.
A class can implement an interface using the keyword implements. A class that implements an interface must implement all the methods declared in the interface.
Okay, so I'll take an example. So interface and interface name. I think same is true for the abstract class also. That if you are extending an abstract class, you must implement the whichever class is extending it must implement all its methods. So it's the same thing here as well. So interface name, declare constant fields, declare method that abstracts that are abstract by default. And in this example, printable interface is only one method and its implementation is provided by the A6 class. So here's an interface. It has void print method, which is public by default. And class A6 implements printable. And because we are supposed to implement all of the methods of an interface, that's why we are implementing the print method of an interface here. Then we have another method called main. Of course, that's just always there in class. And here we are instantiating the A6 by creating an object of that and they're just printing it. Okay. Okay, carry on.
Extending an interface. An interface extends another interface like a class implements an interface in interface inheritance using the keyword extends.
Okay, so there's inheritance and interfaces also. Okay.
In this case, a class that implements the extended interface must implement all the methods declared in the original and extended interfaces.
Okay. So let's take an example. We have an interface A. Interface B extends A. So this is inheritance. This is not implements. This is extending. Okay. So you can extend an interface like this. So you have function B. Then class C implements. So any class that implements must basically have all the methods of both the interfaces. Okay. So for the parent as well as child. So for parent, we are implementing the function A, and for child, we are implementing the function B. Then finally, we have the demo one, and we're just instantiating the class C, and we can then have access to both the methods. In this case, class that implements the extended interface must implement all the methods declared. Okay. Okay. Carry on.
Default interface methods. If a new method is to be added in an interface, then its implementation code has to be provided in the class implementing the same interface.
Okay.
To overcome this issue, Java 8 has introduced the concept of default methods, which allow the interfaces to have methods with implementation without affecting the classes that implement the interface.
Okay.
So the implemented classes do not have to implement default methods.
Okay. So now it talks about that if there's a default method, you don't really need to implement it. So the class that implements the interface doesn't have to basically implement those methods. So there's a default method default method called method two, declaration of default method. And if you come back and look at the example class which implements this interface, we can see that uh, do, 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 do. yeah, you can see that it's not really implementing the method 2 here. It doesn't have to do that, but method 2 will still be available. Just because it's not implementing doesn't mean it will not be available. It has access to all the methods here, including this public as well as default. It's just that if this wasn't default, then you have to implement that inside of the implemented class, but because it has a default access modifier, then you don't have to really implement that. So that's what he's talking about, the default interface methods. Okay. Okay.
Issues of multiple interfaces. Java does not support multiple inheritance. For example, if a class inherits two classes which have a default method each, upon calling the method, the compiler cannot determine which class's default method is to be used.
Okay, so I think this is one of the reasons why multiple inheritance is not available in Java by default. Because if two of the classes have the same default method, then the compiler will get confused about what to do at that point.
To solve this, we can use multiple interfaces. If both interfaces contain the default methods with same signature, the implement class should specify which default method is to be used or should override the default.
To solve this, we can use multiple interfaces. If both interfaces contain default method with the same signature, the implement class should specify which default method to be used or override. Okay. So let's see if it's doing that here. So P1, P2, default method is display, default method is display, implementation. So here test multi implements the interface P1 and P2. So multiple interface. This is multiple interface. And then it has a function called display, overriding the default display. So overriding the default display method. Then it's using the super. Uh, okay okay, so it's using the super to call the display method of P1 and then P2. So when you're calling a function inside of the implemented class, which is the same name function in both the interfaces, then at that point you have to use super and then with the name of the class. So that's how the system will know whose method are you trying to call. Are you trying to call the first interface method or the second one? So that's the solution for this problem of if both of the interfaces have have the functions with the same name. We can use the class name dot super dot name of the method. Okay. Okay, carry on.
Use of static method in an interface. The interface static method is similar to the default method of interface, but it cannot be overridden in implementation classes.
Okay, okay. So static methods are those methods which basically can be used in the child classes without having to instantiate the parent class. That is the definition of a static method. But in an interface, this cannot be overridden by the implementation classes. This is what they're talking about. You can't override it. You can't redefine that method again in the implemented class. Okay.
The static method contains the complete definition of the function, and since the definition is completed, the said method becomes static. Therefore, these methods cannot be overridden in the implementation class.
Okay, so let's take an example. Java program to demonstrate static method in interface. You have an interface called new interface. You have a static method with the keyword static. Then public and abstract method of the interface override method. Okay. So class interface demo implements new interface. The main. Then you are instantiating this demo. Then calling the static method new interface dot hello. Calling the abstract method interface dot override method. Okay, implements the, then we are using this override method. Okay, instead of method. Okay, so for a normal method you are able to override it, but a, no, a static method you are not really overriding it here, you're just calling it here. Okay, multi-threading in Java. Let's see if we have anybody else who can read this. No, we don't. Okay. Right, carry on, Sumaya.
How threads are created in Java. Threads can be created by using two mechanisms: extending the thread class, implementing the runnable interface.
Okay, this is a question in the assignment, which talks about the threads, and they can be created by extending the thread class or implementing the runnable interface. Threads creation by extending the thread class. So the first, there are two ways to do it. The first one and second one. So we are not going to talk about the first one, which is extending the thread class. Okay, go on.
We create a class that extends the java.lang.thread class. This class overrides the run method available in the thread class. A thread begins its life inside run method. We create an object of our new class and call start method to start the execution of a thread. Start invokes the run method on the thread object.
Okay, so let's take an example. Java code for thread creation by extending the thread class. So we have created our custom class called multi-thread demo. It extends the thread class, which is available in the java.lang package. It has a method called run. Inside of that, we will go ahead and use try and catch method. So in case if there's an exception, we'll throw that. We'll go ahead and print thread plus thread dot current thread dot get id. So whatever process is running is gonna get the id of that thread, and it'll print that. In case if it's not able to do that, then exception will occur and it'll go inside of the catch method, and then this exception will be thrown. Then finally, inside of a multi-thread, we basically go ahead and create a variable called int n equals 8, and then we loop through it. Let's say there are 8 threads, so we loop through each of the thread uh, by creating an object multi-thread demo object equals new multi-threading demo. So we are basically instantiating this class that we had extended using thread. And once you instantiate that, we want to call the start method. Okay, and when you call the start method, then it's going to start running it, and it's going to keep on printing whatever we had put in here, which is, so you have thread plus current thread get id, so it's going to get the id of that and it's going to start running that. So coming back and repeating what we have read here, we create a class extending java.lang.thread class. This class overrides the run method available in thread class. So thread class already has a method called run. We are overriding that by redefining that method. Thread begins its life inside the run method. We create an object of a new class and call the start method to start the execution. But where is the start method? Is it start method belongs to thread? I think probably yes. To start the thread, I think it's calling the start method of the thread class, correct?
Yeah,
Yeah. Okay. So when you call that, then automatically this invokes the run method. So I guess thread might have some mechanism in which if a start method is called, it kind of invokes the run method. And run method also belongs to the thread class itself. It's just overriding it here. Okay, so the moment you call start, which belongs to thread, it'll invoke a run, which also belongs to thread, but we have overridden it here. Okay, and then it's going to start printing this. So we're looping it 8 times, so it's going to print the 8 IDs for those threads. Okay, so this is an important one, and this is an example that we can give. Okay, second type of thread creation is by implementing the runnable interface. Go on.
We create a new class which implements java.lang.runnable interface and override run method. Then we instantiate a thread object and call start method on this object.
Okay, so let's see how this is different. So there we were extending the thread. Here we are implementing the runnable. So the previous one was extending a class which is available in the java.lang library, and here we are implementing a runnable interface. Okay, so again, same class name, but this time instead of extending, we are using implements, and that'll be runnable. We again overriding the runnable method called run. Same thing is happening here, exact same thing here as well. But this time we are using new thread again inside of this new multi-thread demo. Okay, and then we call the start method is going to invoke the run method, which is going to basically do go ahead and execute this try, and same thing basically. So there's not like a big difference between the two. There's only two differences, main differences. Here it's extending the thread class, and here it's implementing the runnable interface. And second difference is that here, when you are instantiating the multi-thread demo, just using new multi-thread demo, but here you are basically using new thread, and then inside of that you're passing this as a parameter. So this thread is actually expecting this implementation here. That's a difference. Okay, let me just break it down 1 second. Graph, paragraph. I've sent an invite. You've seen that, right? For
Yeah,
Saturday. Okay. All right, go on.
thread synchronization in Java. If you want two threads to communicate and share a complicated data structure, such as a linked list or graph, you need some way to ensure that they don't conflict with each other. In other words, you must prevent one thread from writing data while another thread is in the middle of reading it.
Okay.
So there is a need to synchronize the action of multiple threads and make sure that only one thread can access the resource at a given point in time. This is implemented using a concept called monitors.
And I think we had something called locking and mutual exclusion and all that. I think same kind of principle is
Using
applied here
OS.
also. Yeah.
Each object in Java is associated with a monitor which a thread can lock or unlock. Only one thread at a time may hold a lock on a monitor. Synchronization provides a simple monitor facility that can be used to provide mutual exclusion between Java threads.
Same thing we spoke about.
Synchronization support is built in the Java language.
Okay, so just to summarize this, basically, when two threads communicate with each other, they might conflict with each other. Okay, so we have to stop from one thread writing data on another thread. So to do that, we have to monitor them. There's a concept called monitor, which basically monitors that only one thread at a time can hold a lock. Okay, you can lock it, and we achieve this with mutual exclusion, which means I think if one of the thread is holding a resource, another thread cannot take that resource until unless that thread basically releases that resource voluntarily. So that's the same concept of mutual exclusion, and locking and unlocking is here. And this synchronization support is built in Java language. So this is the summary of what's been added here, and this is also a question in assignment. Okay, go on.
Thread class methods. Static thread current thread returns a reference to the currently executing thread object. String get name returns the name of the thread in which it is called. Int get priority returns the thread's priority. Void interrupt used for interrupting the thread. Static boolean interrupted used to test whether the current thread has been interrupted or not. Boolean is alive used for testing whether a thread is alive or not. Boolean is daemon used for testing whether a thread is a daemon thread or not. Void set name string new name changes the name of the thread to new name.
There's too
Void,
many.
void set priority changes the priority of the thread. Static void sleep causes the currently executing thread to sleep or temporarily cease execution for the specified number of milliseconds. Void start used to begin execution of a thread. The Java virtual machine calls the run method of the thread in which this method is called.
Okay, I'm not sure if they'll ask for these questions. There's too many. Maybe they'll possibly ask us to give some examples, and we can give some of the examples from this. Just a recap of this. Current thread returns a reference to the currently executing thread. Get name returns the name of the thread. Get priority returns thread priority. Interrupt used for interrupting the thread. Interrupted used to test whether the current thread has been interrupted or not. Is alive used for testing whether the thread is alive. Is daemon for testing whether a thread is daemon. Set name changes the name of the thread. Set priority changes the priority. Sleep causes the current thread to go to sleep for a certain time. Start is used to begin execution of the thread. Okay, go on.
Just like a process, a thread exists in several states. These states are as follows. New, ready to run. A thread is in new when it gets CPU time. Running, a thread is in a running state when it is under execution. Suspended, a thread is in the suspended state when it is temporarily inactive or under execution. Blocked, a thread is in the blocked state when it is waiting for resources. Terminated, a thread comes in this state when at any given time it halts its execution immediately.
Okay, so since we are talking about the thread model or thread states or thread life cycle, like processes have different states. We studied about that in operating system. New, running, suspended, block, and terminated. Similarly, threads have the same thing. This is your cycle starts. Uh, Thread goes in the ready states. Uh, if it is interrupted by something, for example, it requires a resource, etc., it goes in the waiting state, and then continues running once that resource is supplied, and then dead, which means terminated. So new, when the thread is in new, when it gets a CPU time. Running is when it's running basically. Suspended, temporarily suspended or inactive. Blocked, in case if it's waiting for a resource, it is in the block state. And terminated once it finishes its execution completely. Okay, thread priorities, just 1 second. Okay, let's start. Java assigns to each thread a priority. Thread priority determines how a thread should be treated with respect to others. Thread priority is an integer that specifies the relative priority of one thread to another. A thread priority is used to decide which thread. A thread can voluntarily relinquish control. Threads relinquish control by explicitly yielding, sleeping, or blocking on the pending input output operation. In this scenario, all the threads are examined, and highest priority thread that is ready to run gets a chance to use the CPU. So it works on a priority basis basically. Whichever thread has the highest priority is going to be executed first. So that's what it's talking about here, that Java basically assigns a priority to each thread, similar just like your processes. And this priority decides which one will be executed first and how it should be treated with respect to others. And this part talks about that a thread can voluntarily relinquish the control, which means it voluntarily also can decide whether it needs to block itself or go to sleep or pause, etc. Okay, inter-thread communication. To avoid wastage of precious time of CPU or to avoid polling, Java includes an inter-process communication mechanism via wait, notify all methods. These methods are implemented as final methods, so all classes have them. These three methods can be called only from a synchronized method. First method is wait, which tells the calling thread to give up the monitor and go to sleep until some other threads enters the same monitor and calls notify or notify all. Notify wakes up a single thread that is waiting on this object's monitor. Notify all wakes up all the threads that are waiting on this monitor. The highest priority thread will be run first. Okay, so to sum it up, Java has an inter-process communication, and to do that, basically how processes communicate with each other. To do that, it has three methods, which is wait, notify, and notify all. The job of wait is to uh, tell the calling thread to go to sleep or wait until it has been notified to take the next step. Notify wakes up a single thread, notify all wakes up all the threads. Okay, so Maya, go.
Suspending, resuming, and stopping threads. To avoid wastage of precious time of CPU or to avoid polling, Java includes an inter-process communication
Wait,
mechanism.
wait, wait.
Oh, we
Is
the
it
same thing.
repeat? Wait, something wrong here. Yeah, I think it's something wrong here. This is some other content coming in, like a repeat of that. I'll check that later. Let's move on to the next one.
Obtaining thread state. The getState method of thread class returns the thread state. This method is designed for monitoring the system state, not for synchronization control.
Okay, so this basically function gets the state of a thread, and we can define it using get state. Okay, it's fine. Go to number and strings. Number and class and its use is also a part of the assignment. So let's go on.
Number class is an abstract class which is placed in java.lang package.
Okay,
It has four abstract methods: int value, long value, double value, float value, and two concrete methods: byte value and short value.
okay,
Use of number class. Constants defined by the number class, such as min value and max value, that provide the upper and lower bounds of the data type, are very much useful.
okay.
Number class object can be used as an argument of a method that expects an object, often used when manipulating collections of numbers. Class methods can be used for converting values to and from other primitive types, for converting to and from strings, and for converting between number systems: decimal, octal, hexadecimal, and binary.
Okay, so just to recap of this, so in the assignment they've asked about what is a number class and its use. So basically, it's an abstract class, and it's part of the java.lang package. Um, It has four methods: int value, long value, double, and float, and two concrete, which is byte and short. What are the use
What does
cases?
concrete method mean?
So concrete is solid method, I think, but I don't know what it's called in programming. I can check that. Method has complete definition but can be overwritten in the inherited class.
Okay, the opposite of abstract method.
Yeah. If we make this method as final, it cannot be overridden. Declaring a method or a class final means the implementation is complete. Okay. Okay. So use case of the number class is the constants that are defined in the number class, such as min value and max value, are pretty useful because they provide the upper and the lower bound. I think in PHP also the constants are available. Uh, PHP min value and max value, and I've used them in the program, especially to compare. For example, when we have a list of data available and we need to create the min and max. So initially, when we do the comparison, we have to compare the first value against. If you're running a loop, it is supposed to compare two values, right? But when the loop runs for the first time, then it requires something to compare with. How will it compare only one value? So, I mean, second time there'll be two value available because there'll be previous index and the new index, but the first time it will not have anything. So that is the time, this max value, which is like the highest value, upper bound, is available, and then we can compare that. So that's why it's useful. Number class object can be used as an argument of a method that expects an object, often used when manipulating collection of numbers. Class methods can be used for converting values to and from other primitive types, for converting to and from strings, and for converting between number systems, decimal, octal, hexabinary. So for conversion, it is useful. It can be passed as an argument of an object. Just highlight constant defined, useful. Number class object can be used as an argument for converting values. Okay. Remember the keyword, at least we can write in exams. Okay, number class methods. Uh, byte value. It converts the number into a byte type and returns the value of the specified number as byte. Abstract double value returns the value of specified number as double equivalent. This returns float equivalent. This returns value of specified number as an integer. I think these are useful. For example, sometimes we want to explicitly get the data in that data type, let's say integer. So if user enters something, let's say he's entering a string, for example, we want to always ensure that we get an integer value, because probably we want to do some calculation on that, and calculation cannot be done on strings. If he's putting zero in quotes, it's not going to work. Sometimes these functions are really useful, that conversion, that if we use int value and we pass whatever user has entered, then it's always going to ensure that it will convert that zero from a string to an integer, so that then we can perform a calculation. So that way these methods are pretty useful. And this converts float into this conversion double, etc., int value, long and short value, etc. We go on. I think this was the last one we'll be doing today.
The string class represents character strings. All string literals in Java programs such as ABC are implemented as instances of this class.
Okay.
Strings are constant, their values cannot be changed after they are created. String buffers support mutable strings.
So mutable, something that can be changed.
Because string objects are immutable, they can be shared.
Okay. So I got so many methods. Uh, you have char at, it basically returns the character value of a particular index. We have length, returns the length of the string. How in Python we had certain methods, dot length and all of those things. Similarly, here also we have different methods for different purposes. Format, so job of this is to format the string. Substring is going to give us the substring for a given begin index. Then we have contain. So let's say we wanted to check if particular string contains a word or a character. We can get that information using contains. Join, I guess this is joining two strings. Um, okay, and then equals, check the equality of the string with the given object. So if you pass something, I will check if it's equal or not. Is empty is going to check whatever variable you're passing is empty or not. Concat is going to join two things together. Replace will replace that string, the old with the new one. Then you have equals, ignore case, compares another string, doesn't check the case. So that means it'll check two strings, but it'll ignore if one of them has a uppercase or a lowercase. It doesn't matter what case. As long as the characters are the same, it's fine. Job of split is to uh, return a split string matching the regex expression. Interned, I'm not sure what interned is. Index of, I think it'll find the index of a particular character in a string. So yeah, I think tomorrow we'll continue from here. So the way we are doing this is that first day we will do a recap from a certain part, and next day we'll do a recap from like the previous parts, because now it's getting longer and it's not possible to recap everything. So we're breaking those topics into parts. So I'm marking this here. Like, this is where we have to start. So tomorrow when we do a recap, we'll do it from the start up until that point. The checkpoints basically. So let me add this as a checkpoint. Oops. Actually, this one will be the checkpoint because this is what we need to study tomorrow. Okay, for the Saturday session, if possible, cover all the questions related to creating diagrams or anything related to solving problems, not the theory part. See if you can cover that. We don't really have
Okay.
that much time left. Okay, do we have anything else? Yeah, I think that's it for today. Let's catch up tomorrow, same time. And probably we'll do it for 1.5 hour tomorrow since we have missed it for 2 days.
Okay,
Okay.
that sounds good.
Thanks. Bye bye.
Bye.